Which actually brings me to my next question. Now, we have always said that NP-complete problems are very hard or challenging problems. Are there problems that are even more difficult to solve than NP-complete problems? And the answer here might surprise you. Actually, finding an optimum strategy in most games, such as chess or checkers, turns out to be harder than NP-complete. Of course, when I say chess or checkers, I do not mean the normal 8x8 board that you're playing on, but rather it's generalized versions of those games where you can have an arbitrarily large board. The reason, of course, being that if you fix this as 8x8, then the problem size or input size is always fixed. So a concept like NP-completeness does not apply. You always need an input size. But if you take the dimensions of the board as an input size, then certain questions about these games become provably harder than NP-complete. So the problem of determining for a given game position on an n-by-n chessboard, if white can force a win, which means that no matter how good black plays, white can always find a strategy to win. Asking that question is believed to be much harder than solving an NP-complete problem. Now I say believed to be because this hardness requires that P does not equal NP. If P equals NP, then actually many variants of this question here, and there are different ones, will also be solvable in polynomial time. But in the case that P does not equal NP, this problem here is much harder than NP-complete problems. There are even some problems that are provably harder than NP-complete problems. So even if P were equal to NP, these problems would be harder. And I'll give you one example for that.